Okay, this video shows you how to use the dispersion calculator in its most common way. So, as you can see, I've already opened a project. You can go under Accessories and Glass Dispersion Calculator. Now this comes up with a screen where there's nothing listed for the constants. And you can see the minimum wavelength, the maximum wavelength, number of sample points, formula definition up here, or formula name, and then formula definition down here. So what the formula does for you, and the letters here with the boxes, allows you to enter dispersion constants here for the shot formula, the A, B, C, D, E, F, and the associated wavelength dependence there. And then you can calculate and save or calculate and plot associated with a certain dispersion formula. You can also change formulas. There's Selmayr, there's Cauchy, for example. However, the most common way I use, oh, by the way, so the minimum and maximum wavelength are shown here with the number of sample points in between that indicate the fit calculation and what you're going to see or what you're going to say. The most common way I use it is to actually browse a pre-made file, and I'll demonstrate that for you now. So we browse, and then we go to the main OptiScan directory where the program actually is. On my computer, it's in the C drive under OptiScan, and then under the current version, there's a file called Glass File. So open that one up. And then, for example, let's do BK7. Oops. BK7, and there you see it's got the class number there. The 517 is the refractive index, 1.517 is the refractive index at D line, and then the 64.2 is the Abbe number. So we'll take that one. It'll ask you if you want. You don't actually have to replace it, but you do have to say yes here. And then just plot file data, and it will show you the dispersion curve over the wavelengths that are specified in the file. And you can just go in and come up there. There's 532, for example, is 532. Right there, 1.5195. Now, so that's useful. It's also sometimes useful just to take that file and interpret it yourself if you want to have that dispersion relationship in an M file, for example, in a script file. So the way you do that is you go to the directory where the glass files are at, and or you can copy them into the local directory that you're working with. And so for me, that's here. And then I would just copy those into a variable. So let's say S equal load. Let's see, let's go down to the BK7. And copy that name over here. Bring that in. And then let's say I wanted to do 532 nanometers inside of a program. Then I would just say use the interp function, interp1 and S. See, those are columns. So there's the wavelength, and there's the refractive index for the reference, and then it would be 532 e to the minus 9 for nanometers. And there it is, 1.5195. And that's it.